Today we will be looking at two-way frequency tables, one of the last lessons of the year. We still technically have one more, but the other one's like a super short one. So to be successful at this, notice you'll only see like 2 bullet points because there's 2 questions on the test for it. But you know, in order to do those 2 questions, we do have to go through kind of all the notes so that you can understand how to do the questions. All right, and first is that you can read and complete two-way frequency tables. And then if you can calculate the relative frequency for any part of the table and represent it as a decimal and percent. So I am recording now, I'll link it in here, but there's also a lot of helpful videos online. These 2 specifically for how to do the relative frequency, which is what you'll see on the test. Is asking you about relative frequency. The practice I printed, I'm not going to give it out yet until we're done with the lesson. Because while I usually don't mind if you like start to practice while I'm teaching, you really could be doing it wrong if you start it while I'm teaching. Just a little, you have to read it carefully. We will take an exit ticket on this tomorrow, and you'll have another exit ticket for the last lesson. And then you'll be testing for topic 9 this Friday. So this Friday is the day that you get to use your notes. You do not get to use your notes on the weekend. Any questions? All right. Also this Friday is the deadline for late work from the purple folders and the last day that I'm having tutoring. So your topic 8 test scores are in the grade book. I adjusted your quiz scores to match your test score. You know, whatever ones were lower, I bumped it up to whatever grade you got on the test. So right now your grades are 100% accurate. So if you come to me, I don't know, like the week of finals and ask, oh, what can I do to bump up like a whole letter grade? I don't really have anything for you. You need to get a good grade on this coming up test, which I don't think would be a hard thing to do. It's a pretty easy unit. And or come in to retake that topic 8 test this Friday. All right, I'm really serious about not doing it past that day. All right, so for the two-way frequency tables, let's look at some vocab. So first is the quantitative data. So data that can be expressed with numerical measurements. So quantities. Anything that has a number, well, I'll say that sparingly. Any data that you collect that is numerical will go in that category. So what are some examples? What data could I collect that would be numbers? Okay. So here's one, there's mass. What else has numbers? Today would be nice, you guys are already a little bit behind on my other classes. So what can you measure that is a numerical measurement? Length, good. What else? Area. Basically anything that has a number will go in the quantitative data. The categorical data is anything that is not numbers. We also call it qualitative data. So hopefully you've heard of both in science. If not, there it is. Qualitative data. So things that have qualities. So they have some examples here like animal type. If I were to survey you guys and ask you what type of pets do you have, what would you tell me? Dogs, cats, what else? Parrots, fish. I wouldn't ask you what type of pets do you have and you wouldn't say one, would you? No. All right, so anything that's not.
Sorry for the interruption. I need the following students to report to the
So then other types of categorical data, like models of car, favorite song, types of music you listen to, anything that is not numbers is your categorical data. And then we're going to be looking at frequency tables, which are tables that show how often each item occurs in a set of categorical data. So we're not looking at numerical data, just categorical. So let's see if you understand the vocab. It says which of these, if any, so temperature, weight, height, color, which of those would be categorical data? Color, anything else? No, that's the only one in this list. Temperature, represent that with numbers, like the high this week is going to be 100. Weight, numbers, height, also numbers. Example 2, identify whether the given data is categorical or quantitative. So large, medium, and small, what type of data would that be? Categorical. What about 120 feet squared, 130 feet squared, 140 feet squared? Not quantitative. Oh yeah, it is quantitative. Sorry. All right, now let's look at an example of a frequency table. This one's just a one-way frequency table. We're going to look at two-way frequency tables on our test. But just to kind of give you the gist, this is a survey of how students get to school. So a bunch of different ways that were collected. Some of the table is already filled out for you. So what does this 8 represent? How many people take the bus? So 1, 2, 3, 4, 5, 6, 7, 8. Right, that's how they fill it out. What about per car? How many people travel by car? 7. So just count them out. Right, so it is 7. This right here is not filled in. What would go there? And that's because that's the other type of thing that people said, how they get to school. How many people walk to school in this survey? 5. Now, one thing you need to make sure of for the frequency tables is that the total of your frequency table needs to match how many people were surveyed. So how many people were surveyed? And are you reading it from over here or over here? Doesn't matter. Did you count each data point in here? Is it 20? Yes. And then does our frequency table match? Is 8 plus 7 plus 5, 20. So then we filled it out correctly. Questions about that? All right, now this example is actually a good one for something else that's on your test. Let's say students are trying to prove that the whole school, not the whole school, but the majority of students at the school take the bus. Would it be a fair survey if where they took their sample was like right by the bus loop? And why is that? Because then most of the people that would be asked would be people that are just coming off the bus, obviously, if they travel to school by bus. So that wouldn't be a fair assessment. Where should they go on campus to get a fair sample? A hallway, maybe? Where else? I would differ from asking classes, because if someone came in here and asked you guys, you'd probably say car or walk or bus, not like you driving yourself, like maybe your parents driving you. But if you go to like a senior class, they'll all be traveling by car. I would even say maybe not a classroom unless it's like a mixed classroom. Where else would be good? The cafeteria. right? Because everyone has to go to the cafeteria at some point. That would probably be the best place. So the test should not have any sort of like bias. It should just be completely random. All right, now the next vocab word is going to be two-way frequency table. All right, that's a frequency table which has data for two categorical variables, and they're listed as paired values. So like if I took a survey of you guys about who has a curfew, yes or no, and who has a cell phone, yes or no. And then I would pair those values together. Here's another example. So a high school's administration asked 100 randomly selected students in the 9th and 10th grade about what fruit they like best, and then we have to complete the table. So we also need to be able to identify row totals, column totals, and grand totals. So label this on your table. Anything that goes up and down is a column. Anything that goes left to right is a row. All right, and also fix this down here. This shouldn't say 11. All right, so just like how we had that frequency table above, like the total columns should be like in this one, or row, total row, should be how many 9th graders were surveyed. So what do we have to do to figure that out? Add these three numbers together. What's 19 plus 12 plus 23? Not 44, 54. What about 10th graders that were surveyed? How many? 46. Now let's add up the column totals. How many students chose apples? So we have to add these two together and you get 41. What about how many students chose oranges? And then bananas? Good. All right. And then what do you think goes here? And how do you know 100? So it's the total of the blue added together and then the total of the red added together. So it needs to make sense. All right, these two should add up to this number. This row should add up to this number. And then our grand total will always be like the bottom right corner of the chart. Questions about that? All right, so let's go to the back side. All right, so that one was pretty easy. Now let's look at where it's filled in different spots. So where should I start? What would be something that's easy to fill? For this column, what's the total of people that said no? Good. What else can I fill in? Where? Which total? And what would go here? Good. Because 100 minus 54 is 46. What else can I fill in now? How many boys said yes? And then lastly, what are the total number of people that said yes? Good. Double check it, make sure it makes sense. Do these add up to 100? Do these add up to 78, 22, 100? All right, good. You guys try it now. I think there's like 3 of them for you to try. need to read the instructions closely like you did in these two examples. Those 3 tables, I'll give you 3 minutes. All right, so for your turn, part A, here's what you should have. Probably you started with filling in the total for the water, and then maybe you got stuck after that. If you read the instructions, 100 students were surveyed. That is where you get this box, which in turn helps you find this box, then this box, and then the last one. All right, so if you get stuck, you're like, there's not enough information, read the instructions. It probably tells you how many students in total were surveyed, which you would put right there. That make sense? All right, scrolling down then. Here's part B. Again, 100 students were asked. So the 100 should be in the grand total box. You could have started there. Or you might have found the pear total, the banana total, the girls who chose apples, and so forth. But if you got stuck, read the instructions. You should know that the 100 goes in the grand total box. All right, but they don't always have 100 people that they surveyed. All right, like in part C, they had 200 people that they surveyed. So that's why the grand total box is 200 for this one. This one I think was pretty easy. Any questions? All right, so make sure you have these filled in. And also just be able to read it. Like if I asked you, what does the 87 represent? What would you say? The total number of, it looks like they asked teachers, the total number of teachers that prefer smartboard. Oops, I don't know how to do that. Okay. What about this 56? What does that represent? Total number of girls who prefer projectors. So when you pull something from like this part of the chart, that's linked to 2 things, you need to specify. That's not just people that chose projectors, it's specifically girls that chose projectors. How many people chose projectors? 113. All right, that's like a big part of it. All right, moving on. So that's all good. Relative frequencies is more what they'll ask you on a test. So relative frequency is going to be the portion of a data set each category in a frequency table makes up. The frequency of the category divided by the total of all frequencies. So if you want to write that out, you can. Like frequency of category divided by the total of all frequencies, or you could say grand total. All right, so here's just a really simple one, not a 2-way frequency table yet, but it's the results of a survey Kanisha conducted at school. She asked 80 random students whether they prefer basketball, football, or soccer. And here's her data. To calculate the relative frequency, you are taking however many people said that category. So like for football, 32 people chose that. And you're dividing it by the grand total. What's the grand total? 80. So however many people were surveyed. What's 32 divided by 80? Put that in the calculator. 0.40. If you don't know how to go from fractions to decimals, just remember that the fraction bar is a division sign. Do 32 division sign 80 and you get that decimal. Watch your rounding. Don't inconsistently round stuff. Don't round this 2 places after the decimal and then round this like 1. even though I guess you technically could, it would be the same thing. All right, don't just keep the rounding consistent. What about for soccer? How many people chose soccer? And then divided by what? And what's that decimal? 0.35. The others they already filled in, so like basketball is 0.25. For the total, 80 divided by 80, what's that? 1. I'm going to write it as a decimal though, and keep the decimal places consistent since the rest are 2 after. I'm going to write 1.00. Not that it really makes that huge of a difference, but it'll just keep it consistent. So questions about that? All right. Usually we don't put the fraction part, but we're just showing you how we got that decimal. You also need to know how to convert decimals to percents. So how can I convert a decimal to a percent? You could move the decimal. I like just saying timesing it by 100%. All right, yes, you can move the decimal 2 places to the right, but people always forget how many places. So I just say times it by 100%. So 0.25 times 100% is 25%. What's 0.40 times 100%? 40%. 0.35 times 100%? And 1 times 100%. Good. So like your grand totals, if you're writing them as a decimal, should equal 1. If you're writing them as a percent, should be 100%. Questions? All right, we'll do more examples down here. There's types of relative frequencies, which has been tested frequently in the past, not so much here. Like you don't need to like memorize the vocab that we're about to do, but it is helpful. So the first blank is going to be your joint relative frequency. Sorry, I had to read it first. So a joint relative frequency is found by dividing a frequency that is not in the total row or the total column by the grand total. It tells what portion of the total has both of the 2 specified characteristics. I'm just going to underline that part. Next, we have marginal relative frequency. Marginal relative frequency. That is found by dividing a row total or column total by the grand total. It tells what portion of the total has a specified characteristic, so just one characteristic. All right, so here's an example about the same survey we just looked at, except now she's splitting it between girls and boys and whatever sport that they prefer. So first we need to complete the table. So let's complete it together. What can you complete first? How many girls like basketball? 6. And you can find it by doing 36 minus 18 minus 12 or 20 minus 14. What else can I fill in? And how many boys like football? What else? How many like soccer? And then lastly, good. And that's how many people were surveyed, right? So we could have even started there. This one, it didn't seem to matter where we started, but it works, so we did it. So we have our table filled in. Let me see what the backside says. I might need to come back. Now we need to find the relative frequencies. So the ones that we just filled in, so like the 6 for girls that prefer basketball, what am I going to divide that by? 80 in order to get the relative frequency. And then the boys that prefer football was 20. What will I divide that by? Good. Total that like soccer was 28. What do I divide it by? And then total people surveyed was, what do I divide that by? So I'll give you like 30 seconds, practice finding the decimals yourself. So 6 divided by 80, you get 0.075. So don't make it 0.75. There's a 0 after the decimal spot. And we're rounding to the third decimal spot for all of these. 20 divided by 80 should have been 0.25. That one doesn't have an extra number here. If it was there, it would be a 0. Do I really need to put the 0? No, but just so you know. That's why some of these just stop at 0.15. And then 28 divided by 80 is 0.35. And then 80 divided by 80 is 0.1. So 1.000, I guess you could say. So now that we have that, we're also going to answer these questions. These will be as percents. So normally on our relative frequency tables, we don't put the fraction. We usually just put the decimal. So like these right here that I'm highlighting in yellow, these would be our joint relative frequency because they do 2 categories at once. All right, like a joint bank account. 2 people have access at least. This has 2 categories at once. It's just girls that like basketball, girls that like football, boys that like football, things like that. These that I'm going to highlight in blue, these are our marginal relative frequencies. I think of it as like being in the margins of the chart. All right, those are just one category at a time. So like this is girls surveyed. This is boys surveyed. This is total people that like soccer, total that like football, and so on. Does that make sense? All right, so vocab really isn't as big of a deal as the calculations are this time. But it has been in the past. All right, now we're going to answer these, and these will all be percents. You need to know both. So what percent are girls who prefer basketball? Good. If you're not sure, take out your calculator, times it by 100%. What about girls that prefer football? Girls who prefer soccer? Good. What about boys who prefer basketball? Boys who prefer football? And boys who prefer soccer? What type of frequencies are these down here? Marginal or joint? Joint, because it's 2 things at once. Almost done. All right, scrolling down. Some of this is filled in. 25% of the people surveyed prefer basketball. What percent prefer soccer? What? Oh, I skipped. Sorry. What percent prefer soccer? What percent prefer football? And what percent of people surveyed were girls? 45%. And what type of frequencies are these? Marginal. And I just realized it does say right here, but at least you know, these are just the one category at a time. All right, I think, yeah, let's do this one. This will be the your turn, the example B. All right, so first thing you need to do was fill in the table. Hopefully that was like the easy part. All the rows should add up to this total. All the column totals should be these two numbers added together. And then the 92 represents what? 92 people total that were surveyed. So great. Down here are the relative frequencies as decimals, which you need to know how to do. I rounded to the hundredths place. Usually the question will specify, like I know the question on your test will want you to round it to the hundredths place. So hundredths place is how many spots after the decimal? 2. It goes tenths, hundredths, thousandths. So here's what it is rounded to the hundredths place. It should add up nicely. However, right here it doesn't. And they're just it's just because how it rounded. It should like be nice. Like these should add up to this, these should add up to this, these should add up to 1. Right? But I swear I entered it in the calculator the right way. When I rounded to the hundredths, that's what it gave me. Questions? All right, and then how can I convert these 2%? Times it by 100%. So this time I'm not gonna go through the list, but like if I asked you, how many people prefer oranges? What percent of people surveyed prefer oranges? 30%. You wouldn't say 15% because that would be just like the boys who prefer oranges or something like that. What if I asked you how many girls prefer apples? What percent? 17%. So there's that. Questions? All right, I'm going to skip the other your turn, or maybe not. Do that your turn that's on the next page. Don't do this part with the percents, because I think that's pretty clear. Maybe not. Try this one, your turn. All right, so this is like what you'll see on a test. They'll give you the data, and it wants the joint relative frequency of students surveyed. So let me highlight or underline. So of the students surveyed, they like aerobic exercise, but dislike weightlifting. So what number would represent that on this chart? Good, they like aerobic exercise and they dislike weightlifting. 2 categories at once. And for this, what will I divide by? 40. And even if you didn't know like joint relative frequency, what you're supposed to divide by, things like that, it says of the students surveyed. So of the total student survey. So 12 divided by 40 in your calculator is what? 0.40, 0.30. And then times 100% would be 30%. It might say write it as a percent, it might say write it as a decimal. Make sure you know the difference. All right, what about down here? Marginal relative frequency of students who like weightlifting, so don't shout it out yet. What number represents students who like weightlifting? 21. So just the weightlifting it's asking about, just students that like it, not the other ones. So that's 21 divided by what? What decimal is that? 0.53, anyone disagree? I don't have it in front of me, so I don't know. And then 0.53 times 100%. 53%, but. Questions, comments, concerns? All right, one more thing, and sorry, I know it's like on the back side, I didn't print it for you, but I'm gonna have you fill this in. All right, so just at the top, right, conditional relative frequency. Conditional relative frequency, and then write this down. Found by dividing a frequency not in the total row or total column by the total for that row or column. That's the key part there. So not by the grand total. It's found by dividing a frequency not in the total row or total column by the total for that row or column. All right, and here's an example. So Kanisha's survey, the one that's on page 3, we're talking about that one. Out of the total students who prefer soccer, so not out of the total students surveyed, just out of the total students who prefer soccer, how many are boys, and then what's the relative frequency? So how many total students prefer soccer? I'm gonna flip to page 3 for a second. 28 total students prefer soccer. So that's going to be my numerator or denominator. The denominator. Because it's out of the total students that prefer soccer. How many of those students are boys? How many were boys? 10. 10 of them were boys. So go back. So it's 10 divided by 28. So this one's where it's not divided by the grand total. You just have to read it carefully. What's 10 divided by 28? 0.35. Let me double check that. I got 0.36. So round it to the hundredth place, it's 0.36, or what is it as a percent? 36%. Does that make sense? All right, so then I have a U try for you, so I'm going to scroll down. Actually, I'll bring it up more. So in the same survey, Kanisha survey, out of the total girls surveyed, what's the relative frequency that they prefer football? So don't shout it out loud. I'll give you less than a minute. All right. So out of the total girls surveyed, that's the key word, not out of all the people surveyed, just the total girls surveyed. How many girls were surveyed? Good. So is that my numerator or denominator? And then it says, what's the relative frequency that they prefer football? So out of the girls, how many prefer football? So that goes on top. What's 12 divided by 36? 0.3 repeating. Let's round it to the hundredths, which would be 0.33. And what would that be as a percent? 33%. So do you need to know necessarily that it's conditional relative frequency? No. But you do need to know how to read it closely enough to where you know what to divide by. Questions, comments, concerns? All right.